she is going to pay back 11 times more whatsoever you have invested.
Welcome back, everyone, to the Dairy Science Digest. This is the podcast designed to bring the Journal of Dairy Science straight to the ears of dairy producers. I'm Reagan Bluel from the University of Missouri Dairy Team, and today we have on the lineup Dr. Arshad from the University of Wisconsin. We know that way back in the late 1800s, choline was identified in the bile of cattle. However, it wasn't until about 20 years ago that this choline became a real hot topic, especially in the dairy research circles. And this research and good news about choline continues on in dairy cattle rations, and it continues to be generated here today. So we are featuring an article that's published in the Journal of Dairy Science that's a little bit different. It's a review of literature or a deep dive into the years of research, all summarized in this particular paper titled Exploring Choline's Important Role as a Nutrient for Transition Dairy Cows. So Usman, welcome to the Dairy Science Digest. Before we get going, could you please tell us a little bit about yourself?
Thank you, Reagan, for the opportunity to dissect this topic. I am Usman Arshad and I am from Pakistan. I finished my vet school and master's from University of Veterinary and Animal Sciences in Pakistan. Then I have strong interest to learn more about dairy cattle nutrition and reproduction. So I earned an assistantship and to pursue my PhD degree under the supervision of Dr. Jose Santos from Department of Animal Sciences, University of Florida. So I finished my PhD last year, and now I am working as a postdoctoral research associate funded by Dairy Innovation Hub at University of Wisconsin Madison under the leadership of Dr. Heather White.
Very good. Well, welcome to the Dairy Science Digest, and I just want to kick off the entire discussion about choline. We've heard about it being in dairy cattle rations for quite some time, but asking you a little bit about what exactly is choline?
So choline basically it is referred as it's a quasi-vitamin. It has some properties like vitamins, but it doesn't fit exactly on the definition of vitamins. And I'm going to tell you why. If you see the role of vitamins, they act as a cofactor or enzymes to carry out the several essential biochemical reactions in the body. And those vitamins, basically, they are required in very small amount, like in milligrams, to carry out those functions. But choline, if you see the requirements of choline in ruminants or in humans, irrespective of the species, the requirements are always in grams. So they are needed in much more quantity than a typical vitamin is needed. Choline, especially during the transition period, the role of choline is so much that it involves in so many different pathways that overall concentrations of choline they are very very low levels. So that's the window when even body is synthesizing or has the ability to synthesize choline, but the requirements of choline during that window are so much because of its involvement in different pathways and physiological aspects that the synthesis of body just does not help.
It's just not enough. And so we run the opportunity to supplement choline. So let's talk a little bit about how choline works at the cellular level, being utilized with phospholipid production. What are phospholipids and why are they important, especially to the transition dairy cow? Let's zoom into the cellular level.
Yeah, so the phospholipids, basically, phospholipids are very much essential for life, I would say, because if you just talk about a cow and you break a big cow into very small cells,
Uh-huh.
the cell membrane, the membranes of every single cell in our body or in any animal's body, basically they cannot survive if there is not enough phospholipids. So basically the membranes of the cells, they're comprised of phospholipids. And among them, there are several different classes of phospholipids. Phosphatidylcholine is one of that.
Mm-hmm.
Phosphatidylethanolamine is another one. Phosphatidyl serine is a sphingomyelin. So there are so
Mm-hmm.
many phospholipids. And then those phospholipids are not only involved in maintaining cell, but they carry out several important functions in the body. So for
Mm-hmm.
example, the movement of my hand is under the influence of how nerve impulse is going to my brain.
Mm-hmm.
And those nerve impulse, the sheath, those nerves is comprised of myelin sheath, which is comprised of sphingomyelin.
Yes.
Let's talk about the movement of the cow. So the movement of the cow is dependent upon the fact that if that cow's brain or if that cow's body is capable of having enough acetylcholine, which is an important neurotransmitter which facilitates the movement of the body. So when you talk about acetylcholine, it is also being synthesized from choline. So if you talk about those phospholipids in terms of products such as milk fatty acids, so those milk fatty acids, the membrane of those milk fatty acids, which eventually going to make the component like a milk fat, those are based upon phospholipids. So phospholipids play a very important role in determining if the cell is going to live or not, and if the cell is going to perform properly or not in the body.
So, yeah, phospholipids really is the building block of the entire cow, the entire mammal. And so, here, in essence, what you're saying is choline's required for life. Those cellular functions, the cells in general, during the transition period are they're just challenged. Everything's challenged during the transition period. And I know all my regular listeners, they know I'm a sucker for the transition cow and really identifying research-based methodology on how we can manage her way through a smoother transition and therefore an improved outcome in the subsequent lactation. So can we zoom in on how does choline help that transition dairy cow succeed?
So transition cow is really an important component to have a successful lactation cycle for a cow. Choline, basically, if you look in that window, what happens 21 days before and 21 days after calving. So during this transition period, the cow, she moves from a stage where she is pregnant, but she is not producing milk. As soon as she calves, then she is not pregnant, but she is producing almost 45 to 55 kilograms of milk, and that's a lot of milk. And in the meantime, as she approaches to calving, almost 30 to 35% cows, they just drop their intake. It's just physiological.
Yeah.
When these challenges occur, cows, they usually start mobilizing their body reserves. And when they do mobilize their body reserves to produce lots of milk and maintain the physiological functions, but this puts liver at a risk of receiving loads and loads of fatty acids. So when cow
Mm-hmm.
mobilizes her body fat, the concentrations of fatty acids in blood, they
Skyrocket. Yeah.
exactly. And then there is a capacity in liver to handle those fatty acids. So what happens eventually, liver says, hey, I cannot just have more fatty acids to oxidize. Those fatty acids just start to re-esterify into fat.
Mm-hmm.
So they just start depositing in liver. And eventually the liver, which was normal before calving, it starts to accumulate fat. And eventually we say that cow has hepatic lipidosis or
Yeah.
cow has fatty liver. And based upon the degree of fatty liver, it can be very detrimental to the health of the cow. So one major factor where choline can get into play is choline helps in the synthesis of phospholipids. And mainly when we say this, it's actually phosphatidylcholine. And phosphatidylcholine is basically required for the synthesis of very low density lipoproteins. Very low density lipoprotein is a protein which makes sure that whatsoever amount of fat in terms of triacylglycerol is deposited in the liver, it is exported outside of liver. So
Mm.
just think of if I have to get to Missouri and I am coming from this medicine, I need to put myself in a plane or in a car or in some vehicle so I can go there, right?
Yes.
So this very low density lipoprotein, it acts as the same way as a carrier. If
Mm-hmm.
you have enough very low density lipoprotein in your liver, the triacylglycerol will get packed into that VLDL particle and it will export outside of liver.
Yeah.
Now, if you see evolutionary point of view, If you go back into 1920s or 1950s, we did not had cows who were producing 50 kilos, 60 kilos of milk, right? Now,
Different.
exactly. So now those cows have been selected for increased milk production. So back in 1950s, the cows were producing very small amount of milk. So they were not mobilizing huge amount of their body reserves. So hepatic or fatty liver probably was not an issue at that time. But now with the fact that cows are producing so much milk, which puts the liver at a risk of developing fatty liver.
Mm-hmm.
And if you ask me what is the number, almost 50 to 60% of the cows at a given dairy herd which undergo the process of calving or parturition, they experience moderate to severe degree of fatty liver.
Wow, that's a lot. Yeah.
Exactly. Now, cows just do not have enough very low density lipoprotein synthesis in the liver. If the cow needs to generate more very low density lipoprotein, the precursor is phosphatidylcholine, which cannot be synthesized if there is not enough choline. So certainly, if you are feeding choline, you are providing additional source to the liver that can operate its functions optimally. If you are feeding choline, it has very pronounced lipotropic effects. So when we say lipotropic, it has pronounced effects of mobilizing lipids from liver into the blood circulation. Now, when this happens, there is less fat accumulation in the liver. And if there is less, because fatty acid or lipid, they're very lipotoxic if they are staying in the liver. So if the liver stays healthy, there will be proper synthesis of glucose, and we know that lactose is
Mm-hmm.
synthesized from glucose, so the milk production of the cows will not be compromised. The acute phase response or the inflammatory response, if there is less inflammatory response at the level of hepatic tissue, then it will be beneficial to the cow. And then we have very cool results from Michigan State University, from University of Wisconsin Madison, and from University of Florida. There are three independent randomized complete block design experiments which shows that if you are feeding choline during the transition period, they just not only improve the hepatic tissue health, but they also improve the production. On top of that, the cows were producing almost 2 to 3 kilograms more colostrum. So you are getting benefit in terms of more milk, more colostrum, and overall the smoothness in the transition period gets improved with this dietary intervention.
It's just a win-win-win, you know, and when I saw your paper, it was so exciting to revisit the topic because I know this was really popular about 20 years ago, but you don't hear about it in popular press anymore. And frankly, there's a lot of producers that maybe choline's fallen out of their diet or their transition diet in a time of low milk price. Maybe it got on the chopping block. It's important to revisit these diets with some regularity to make sure that you're providing her with the building blocks that she needs to create these low density lipoproteins and therefore protect her liver from fatty liver. And just, it's a win-win-win, right? So let's circle back a little bit. You were saying about the milk yield response, and you had quoted a paper talking about how you see a response not only in the colostrum production, but also up to weeks on end after the supplementation has stopped. Could you expand upon what should producers expect to see as far as total volume of milk generated in cows that have been treated with rumen protected choline during the transition period?
So I think that's a very valid question in terms of dairy producers. If I'm going to invest something on my cows, I should know what will be the benefits of that intervention. So let me put this in a perspective. Whatsoever happened so far with the choline nutrition. So back in 2020, we conducted a systematic literature review and meta-analysis to determine the effect of supplementation of the rumen protected choline fed during the transition period in cows. So what we really did, we collected all the papers which were available in the literature, starting from the very first research work which was done in transition period with choline, all the way until 2020.
Hmm.
So we found 21 independent, randomized, complete block design experiments In simple words, there were 21 experiments with almost 1,300 dairy cows
Mm-hmm.
where half of those cows were fed with choline, any rumen protected choline, and half of those cows were just did not receive choline during their transition period.
Mm-hmm.
And then when we looked at what happens to the production performance, we observed that cows which were supplemented with rumen protected choline, they produced 2.2 kilograms daily milk yield, more than those cows who just did not receive choline.
That's about 4.5 pounds. For those of you that don't want to convert, that's no joke. And 4.5 pounds over what duration?
Exactly. So we had very first study in our meta-analysis at in 2000, and the latest study in that meta-analysis was done in 2020. So that's results which I'm telling you based upon 20 years of these studies. Now, what happened between 2020 to 2024? In those 4 years, there have been independent experiments conducted at University of Florida, at Michigan State University, at University of Wisconsin-Madison, and other different regions of the world where I think there are 7 or 8 new experiments were conducted, but they looked at what happens to cows who were fed with or without choline. So even in last those 4 years,
Mm-hmm.
the response in terms of milk yield has been very consistent. In fact, the range which we observed, it went from 4.5 pounds to somewhere around 7 and 8 pounds of milk. That's a huge range.
Right. Yes.
And we are not talking about experiments with 10 cows per treatment. We are talking
Mm-mm.
about experiments with hundreds of cows. So let me just give you a perspective. So at University of Florida, 2 studies with 220 cows. At University of Wisconsin-Madison, the study which was conducted by Heather White's lab, in that study had 141 cows, and another
Mm-hmm.
study at Michigan State University, it had 60 cows. So if you just compile the data just from last 4 years. So there
Mm-hmm.
has been data for almost 400 cows which were fed with or without choline, and they produced somewhere between 4.5 to 8 pounds of more milk.
That's science you can rely on and set your management towards for sure.
Exactly. Great benefit in terms of sustainability to a dietary intervention.
So, what exactly is the mode of action? I saw in your report that maybe there was some discussion about the intestinal lining of rats. Could you expand? Is that something that we can expect an intestinal lining in the dairy cows to be impacted?
In rats and in monogastric, studies have been done. So when monogastric, especially rat and guinea pigs, when they were fed diet without choline, so they observed that the integrity of the intestinal cells in the intestine, it gets loose. So the intestine was permeable. So there was a chance of leaking antigen from intestine and induce inflammation in those
Sure.
monogastrics. So what happened basically in dairy cows, and because after calving there has been a strong evidence that cows just do not consume enough feed, so this puts in a perspective that cows are not consuming enough feed, and there is an intestinal disruption because of that.
A leaky gut.
Dr. Lance Baumgart lab from Iowa State University, he has done so many experiments showing very clearly that whenever you restrict the feed of the cow, it induces intestinal perturbations. It basically it is they referred to leaky gut syndrome.
Mm-hmm.
Another possibility of leaky gut syndrome is heat stress.
Sure.
So in heat stress, cows also experience this. So now what we did basically, we induced this leaky gut syndrome in Holstein cows using a feed
Mm-hmm.
restriction model, and we supplemented them with choline. What we observed is that choline-fed cows had 5 to 6 percentage point more digestibility of fat. So
Fantastic.
now, if we talk about this in transition cow perspective, although this 5 to 6 percentage point more digestibility of fatty acids is not a huge number, but it gives almost 50 to 60 grams more
Energy.
digestible fatty acids to
Yeah.
the cows, which she can use for the synthesis of milk. And if you just do the math in terms of net energy of lactation of the fat content,
Huge.
you have almost zero point 0.4 to zero point 0.5 kilogram, or you can say 1 pound more milk from just because of the
Improvement.
intestinal health of that cow is improved. Although there is very small evidence for that in transition cows, but there is a very possibility that choline is also facilitating this aspect of the cow.
Oh, that's so fantastic. And she just becomes more efficient in that time when her intake, you know it's going to be low. If she can make every single tiny little molecule work harder, that's tremendous. It's really good.
I think there are several physiological possibilities that why choline-fed cows observe this kind of huge response in terms of performance. So the first thing is when we see a cow is doing very well in terms of production, it just does not necessarily mean that we change something in her body that is only responsible for increase in milk production. What it really means is the cow is doing well in terms of its metabolism, its health, and the extraction of nutrients from the diet.
Mhm.
So when we think about choline, one possibility is during the transition period, let's say before calving. So what if choline is enhancing the mammary epithelial cells? What if there
Right.
is more number of mammary epithelial cells in
Wow.
choline-fed cows at the time of calving that helps that cow to produce more milk? Because when we looked at in last experiments, which I just showed you across all these universities,
Hmm.
we always observe 4.5 to 8 pounds more milk, but we never really find any difference between the dry matter intake of choline fed versus no choline fed cow.
Really?
So if the dry matter intake is pretty much similar between two different treatments, one with choline, one without choline, then why they are producing more milk? So one possibility is what if choline is involved in synthesis of phospholipids, like I said before, so
Sure.
it helps to generate more epithelial cells, which are going to actually secrete more milk. That is one thing.
Yeah.
The second thing is the impacts of choline over the hepatic tissue health. So we did very cool studies. Not only our group at University of Florida did, Dr. Rick Grummer's lab back in 2007, he also did very cool stuff with dry cows. So what Dr. Grummer's lab and Dr. Santos' lab did in dry cows, they actually induced fatty liver in almost 230 cows.
Wow. Yeah. Oh
So when
man.
those cows, exactly, so when those cows developed fatty liver, then they supplemented those cows with choline, and what they observed that choline was able to reduce amount of triacylglycerol from liver.
Wow.
So cows which were fed with choline, they had reduced risk of developing fatty liver as compared to non-fed choline cows. If that happens in the prepartum period, there is a strong rationale that it would also happen in the postpartum period. And in fact, there have been 4 or 5 different studies which also shows that choline-fed cows during the postpartum period, they also had reduced risk of fatty liver. So that is another possibility that the hepatic tissue metabolism gets improved when the cows are being fed with this choline.
No, that's very interesting. I missed that paper somewhere where the induction of fatty liver. So this can even be utilized as say a bit of a treatment if you know you've got a group of animals that are predisposed to fatty liver. Would that be correct?
Yes.
So, like your transition cows that perhaps maybe have a body condition score that's greater than what we really target for, that you know are going to be heading into that negative energy balance and therefore high rate of lipolysis.
Yeah, so I think that is a whole different domain that I would like to address in a detailed way. So one of the major aspect in deciding if the cows should be fed choline or should not be fed choline depends upon the fact that what is the body condition score of the
Hmm.
cows. Traditionally, it's been thought that cows who have more body condition score before calving,
Hmm.
they should be only receiving choline because there is a strong association of high BCS cows prepartum period with the fatty liver in the postpartum period.
Hmm.
But we actually conducted a study where we have 220 cows from University of Florida group. What we did in this study, we had half of those cows received choline and half of those cows did not receive choline during the transition period. Okay. And then we stratified those 220 cows in terms of their body condition score.
Mm-hmm.
So we had two cohorts where we had very skinny cows, and then we had cows with high body condition score cows or obese cows. And within each category, we had control cow and rumen protected choline fed cow. So, irrespective of the fact that cows were skinny or cows were obese, the cows produced 4.5 pounds more milk
Mm-hmm.
in their postpartum period. So, it should not perceive the fact that choline feeding should be only helping the obese cows, but in fact, choline feeding, yeah, it helps the skinny and the obese cows.
Everybody.
It should be for all of the herd and not just the cherry picking some cows for this intervention.
Well, and isn't that easier? That way you can just have confidence knowing that you're spreading this management choice across the whole board. You don't even have to create a separate pin. 42 days of commitment to feeding this rumen protected product could make a huge difference in the liver health and overall health of your transition dairy cow and overall your profitability. Oh, this is
Exactly.
good stuff. Fantastic. Well, okay, and I know you talked a little bit about the inflammation, and I know that's kind of part of the leaky gut, but there's also inflammation around the hepatic tissue. Let's just talk about inflammation in general and how choline helps limit inflammation and how that might be playing a role in the improved milk production for your transition cow.
So generally, inflammation, it's a natural response of a body against any pathogen. So whenever a cow encounters with a bacteria, let's say a cow just calves and she has, I don't know, she just experienced retained placenta or metritis or any other periparturient inflammatory disorder. So the body is going to act naturally to remove that pathogen, and basically the liver is responsible to generate acute phase response where different anti-inflammatory proteins they are being secreted in the blood, and which helps in the phagocytosing and in removing that pathogen. But the issue is when this inflammation goes prolonged or when this inflammation gets to chronic level, then actually it affects the animal performance. So let me give you an example from a very cool experiment which was done by Dr. Lance Baumgart lab at Iowa State University. So what they actually did, they injected a bacteria. It is a pathogen. So they intentionally injected LPS to a cow, and then they got to know that when the cows were in acute infection, their immune cells, they were consuming almost 1200 grams of glucose, and that's just they observed in the first 12 hours.
Wow.
So if you just talk about a day, if in an acute inflammation, if it's going for a day, we are talking here that almost 5 pounds of
Wasted energy.
glucose is
Yeah, wasted.
just being consumed by those immune cells. Now,
Mm,
what happens when there is so much consumption of glucose is being done by those immune cells, the body, it reroutes its priority and it changes its priority towards the immune component as compared towards the milk
milk
synthesis. So
production.
all that glucose, which could have been part of lactose and for this milk synthesis, it's just rerouted towards the immune component now.
Wow. Yeah.
So that's where the cow, she just, I wouldn't say she stops producing milk, but the production gets to half and she just produces very less amount of milk production.
Sure.
You certainly want to avoid that in your dairy herd. And I guess the dietary interventions which limit the inflammation, especially after calving, they are very beneficial. Now, what happens if you are feeding choline? So basically, choline, like I said, it improves hepatic tissue metabolism. It facilitates the export of fat from liver into the blood. So basically, the load of the fatty acids in liver will be most probably minimal in choline-fed cows as compared to non-supplemented cows. So the inflammation at the level of liver
Mm.
will be less intensive. And then when one of the aspect of our meta-analysis was to see the effects of choline on the health of those cows, interestingly, we found that cows who were fed with choline, they had reduced risk of mastitis and they had reduced risk of retained placenta. So somehow we still do not know the exact physiological possibilities how choline facilitates the improvements in the immunity of those cows, but certainly there is something going on which facilitates a cows to have a better immune response towards infection. You have less inflammation, less wastage of glucose for that immune cells, and you have more production.
Yeah, golly, if this isn't getting me excited about choline, I don't know what will. You've given us so much sound science with so much backing that we know that we can trust these datas. But if there were one particular thing about choline that you would like boots on the ground dairy producers to gain from this informative summary, what would be the one take home you'd really encourage them to hear?
So I guess cows, they just need choline during the transition period. It's the time when they just do not have enough choline in their body to regulate their body function. So if you help her during that window, she is going to pay back
Mm-hmm.
11 times more whatsoever you have invested in that cow.
Wow.
So I guess if you want to have a smooth transitioning from prepartum to postpartum period, from non-lactating to lactating period, just for those 42 days, 21 days before to 21 days after, these cows, they certainly need choline, which will eventually pay you back.
Wow. 11 times. Wow.
Yeah. So if you just want to give you a more detail on returns on investment perspective, so let's just do a little math here. If you talk about what is the cost of a rumen protected choline product, so irrespective of the fact whatsoever product you consume, so the cost is almost 30 to 35 cent for 60 grams of rumen protected choline product.
Okay.
The 60 grams of rumen protected choline product gives cow almost 12.9 grams of choline ion. Although we daily definitely we don't know what is the exact requirement of choline in the lactating period, but based upon the literature from last 24 years, it seems that at least 12.9 or 13 grams of choline should be fed during the transition period. So let's just stick to that criteria. So if the price of 12.9 grams of choline ion is 30 to 35 cents, so for 42 days, 21 days before to 21 days after calving, if you just multiply 42 with 35 cents, it's almost $14.7. So if you are investing $14.7 on a cow during the transition period,
Oh man.
how it's going to pay back.
Yeah.
There is a very cool data on almost 400 cows. So two independent experiments were done at University of Florida. Two experiments were done at Michigan State University from Dr. Barry Bradford's lab. Two experiments were conducted here at University of Wisconsin-Madison in Dr. Heather White's lab. So we are talking here hundreds of cows, almost
Mm-hmm.
400 to 500 of cows data. And all of those 6 papers have been published in Journal of Dairy Science. So what really happened is, so in those experiments, all cows received choline at least 21 days before calving, and then they stopped feeding choline 21 days after calving. So they fed only those in that 42 window. So when they stopped feeding choline, what they observed for the rest of 40 weeks in lactation, the
Mm-hmm.
cows were still producing 4.5 to 7 pounds more milk.
Yeah.
So now you just invested $14.7 in that 42 days of window, but the cows have been producing even after the fact. Now they are not being fed with choline. So they kept producing 4 to 7 pounds of more milk until 40 weeks of lactation.
Yeah.
So if we just consider first 25 weeks. Let's just do not go to the extreme. Let's just go to the 25 weeks after calving. If you just multiply 4 pounds more milk for 25 weeks, that is almost 750 to
Yeah.
800 pounds of more milk.
Yes.
Now, if the price of the milk is 20 cents per pound,
Yeah.
the expected return would be $157.
Yeah. Per cow.
So now, if you just minus your $14.7 investment out of this 157, you are receiving $142 benefit, which is like 11 to 1
Yes.
return over investment.
And that's in milk
So,
alone.
and
That's not calculating any sort of labor of just the enhancement of having less of a problem child. That transition cow is such a problem child. If something goes wrong, you pour yourself into that cow to get her through. And so not only are you getting more milk and the value of the milk, but you're getting less headaches. It's so nice. It's
exactly.
lovely.
And it's not that those cows were consuming, more feed as compared to non-supplemented
Just more
cows.
efficient.
So that the dry matter intake of those cows between controlled treatment and a rumen-protected choline supplemented treatment, it was exactly same. So it means that the efficiency of those cows in converting diet into milk was way more
It's awesome.
than a cow which was just not receiving this choline.
For 42 days of investment. Wow.
Yes, 42 days of investment.
This has been so informative. Thank you so much for your time to get us all fired up about choline. Listeners, thank you for your time. I applaud you for taking time to think about how this rumen protected feed additive could impact your transition cow's energy metabolism. I've really enjoyed this conversation, and it's been the April edition of the Dairy Science Digest, which is a monthly podcast project to bring the Journal of Dairy Science straight to your ears. We highlight peer-reviewed research articles in press because this is sound science that you can base your management decisions around. So if you like this, please be sure to share and subscribe and get future editions straight to your cell phone. This is Reagan Bluel with the Dairy Science Digest, and I hope you have a great day.